Hello and welcome to this video series on Pandas library. And Pandas library is one of the main libraries we are going to be using in our Python. And we will be using this in our course quite often. Therefore, it's an important series and you need to take attention and you need to actually code along and enter all the code that I am working with here to try and make sure that you do understand this library and how we create these Panda functionalities and how we manipulate these series and data frames and so on. So in Pandas, series are actually similar to arrays, and we have already been exposed to arrays when we looked at numpys. And the difference between arrays and series is that arrays they have indexes, but we actually just access them by indexes which are assigned to them, which are started at index 0 all the way to n. However, in series, we actually label the array contents with with the actual label, which is in this case the index itself. We can force a type of index in series. So instead of having the automated series, which is 0 to n, we can actually use similar to dictionaries, where we can have a key, and the key in this case can be the label, and we can access and manipulate based on these keys. So let's start and see how we create a series. But before we can use the library Panda, we have to import this library into our code. So if I run this, it should actually say that it's in and it's run, and it should reply by not giving me an error. If it gives me an error and says Panda is not defined, then that means I don't have Panda installed in my environment, because it doesn't come pre-installed in the environment. We have to do that automatically. Therefore, to do that, I have to navigate to Anaconda. Then I need to open Anaconda prompt, and in there I need to type pip install pandas. Okay. Now, if I execute this command, then it should actually run without a problem for me, and it should install pandas. However, in my case, when I run this command, it will come back and says requirement is already satisfied. Therefore, it will not install anything because it's already installed. It will tell me it's already satisfied, and it will give me the version of pandas that I already have installed. And if I run it, you will see now it should come back saying requirement already satisfied, and it goes further and it tells me the Python that it can use, and it tells me the version that of pandas that I have already installed, which says is 2.1.3. So I am okay. I don't need to do anything else. I can close this and come back to my Jupyter notebook. Now, how do we create a series in Pandas? There is a number of ways to create a series in Pandas. First of all, we can use a function called series, which we will call from Panda. So the way I call it is by saying pd.series. So it's pd pandas dot, and I call the function that I want, and this is true for all the functions that are available in Pandas. And then I can use pass the parameter that I want to use to create this series. And in this case, we can actually use list, or we can use array, or we can use dictionary to create a series. So let's look at the first one, which is using a series. So if I hit the run here, as you can see, I created a series called data, and I used a list and assigned that into data. So if I run this, it should actually gives me the list. Now, if I go and type data there, print data. Look at the difference here. So if I comment this here, and if I run it, this is my list, okay? And we have seen this before. Now, if I want to see the series, and I want you to look at the difference between the list and the series, you need to understand the difference between them. Then, can you see the difference now? The series is actually already telling me what are the indexes, and it tells me the content at each of the indexes. But also, when we printed the list, we printed it as a row, okay? While when we are printing the series, we are printing it as a column, and that is a big difference between the two, because when we access it, or when we have a multi-dimensional series, then it becomes different. When we have more than one series and we want to look at them, then we start to call them data frames. Then we need to be able to access them, and the data frames, then we will have probably titles for each column, and then we have data stored in each column, and then we can access them based on this information. So next, we can create a list using an array. So what did I do? I created an array called data_array, and I called numpy, and from there the function array, which will take a list in this case and convert this list into an array. So if I do the same thing here, and if I print, and I can pass to that the array, and I comment this again. If I run this, this is my array now, okay? And it's actually stored the data in the array and printed the array. And of course, if you compare that to the list, you can see the difference between an array and a list. We don't have the comma separating the variables, while if I am looking at the list will actually have the comma separating the variables. Now, if I go and print the list created from this array, then it should actually give me the indexes and the content, and it will give me the data type at the end of the list. So this is the major difference between a list and an array, a series and an array, a series and a list. And let's see how we actually create from a dictionary. So you know how to create a dictionary, and you can see, and in the same case, I will actually print, and I will print the dictionary. And I will comment this. And first we will look at the dictionary just to remind ourselves. This is our dictionary. We have the key and then the content, the key and the content, and the key and the content, and they are separated by commas. Now, if I uncomment this series and look at the series, then you can see we have the series now as a column not as a row. And what we actually did in this case, we took the key and, or sorry, the series function took the key and used that key as the index for the content. So at index A, we have 10. At index B, we have 10. At index C, we have 10. So in the use of dictionary to create, we take it as the key as the index, while in the other two examples where we used a list or an array, we automatically assigned the index from 0 to n. Okay, so or n minus 1 rather than n, sorry, because it's n minus 1 the index. We start at index 0. So this is the difference between creating from a dictionary or creating from an array or a series. However, if I am using a list and I want to create a series and I want to use my own index, IO customized index, then I need to create another list which contains the indexes, and then when I call the function series, I can pass this customized index also as an argument, and then the series function will take the list, which is the data, and will take the other list, which is the indexes, and it will create a new series, and now containing the customized index and the data which we pass to it as such. And this is how we actually do it. Can you see? I have called the function from the PD library, and then I passed it the data in the form of a list, and then I passed it the indices which I want, the customized indices, in the form of a list. And then when I run this, it should actually tell me or provide me with a new series, and in this case it will be the series with the customized index forced into the index. So if I run this, you will see that it's actually customized index in this case. Also, I can actually create customized index with using the series, and I specify not just a letter, but I can use full words or names or anything that I want. So I said first, second, third, and fourth, and it will create it exactly the same as the previous, and it will take first as the first index, and the word second as the second index, and the word third, and so on, and we can actually see that being created. I can also create a series with a scalar where I can provide the indices, and I can provide a scalar, and then I will ask this function series to create a series using that one scalar and assign it to all the indices that I have. And as you can see, if I run this, it actually have one scalar, which is 5, and I have all these indices, all 5 of them, and it will take this scalar and it will enter it into each. So I can customize the content of this series based on whatever I want, and it will repeat for me, as you can see. So if I run this, it actually gives me the series, and it gives me the data type which is entered there. Or I can actually, instead of having integers or floats series, I can have it using any type of data, and in this case I am actually using a string, and my string that I am actually creating the list from is actually apple, bananas, cherries, date, and elderberry, and I can create it, and automatically it will give me the indices as it did with the integers. So if I run this, it automatically indexed this list for me from 0 to 4, and it actually gave me the data content. So that means that list can take any data type. So it's not specifically for integers or numbers or floats or whatever it is. It can be any data type, which means then I can actually use Boolean data, or I can use text, or I can use numbers, which are in two forms, integers and floats, and so on. So let's see how we can use the Boolean data. And I created a list of Boolean data using true and false. And then I can create a list using this Boolean data, and it will give me a list, and it will tell me the data type, and it says it's Boolean, the data type. I can also include data. However, when I want to use date and time, I have to bring date and time from a library called date and time. So there is a library in Python, and it's called date and time. So I'm actually bringing from that library date and time. I'm bringing date and time. So if I use that date and time, I can create a list, and I have three parameters here: date and time to actually tell me the type, and so it's 2023, and it's January, and it's the first. 2023 February, and it's the first. 2023 March, and it's the first. Therefore, it will create the list for me because it's within these square brackets, and then I can use this date and date list in the function series, and it should create for me the series. And the series, as you can see, index, and it will take the content of the first index as January 1st of 2023, or then second index will be 1st of February 2023, then March 1st 2023, and it will tell me the data type is actually date and time, and it's 64 bits. Okay, then if we can create from individual types of data these lists and series, then if I mix them, and we know that we can create a list of mixed data from when we actually did the crash course on Python, then there is nothing to stop me of creating a series which contain a mix of data. And as you can see, I have created a list of mix of data where I use integer, I use string, I use Boolean, I use float, and I actually included nothing, which means I don't have data. I have a location in the list, but I assigned nothing to it, i.e. it's empty. So if I run this, it tells me it's an integer, it's apple, it's Boolean, it's float, and it's nan, which is nothing. Okay, and it tells me now that data type is object because it's not defined as an integer or a Boolean or as a float or as any type of data. It's an object. Okay, therefore now we see that we can create a series of objects, which is different data types, mixed of different data types, which is great, and it's a good way. So now we can see even when we have data which is missing, i.e. we have an item in our data, and this item contains a number of variables, but one of the variables doesn't contain any data, and we call that missing data. Therefore, we know that in Panda, we will be able to even view this and deal with it if we have to actually deal with it. And I will talk about how to deal with missing data in a little bit. Okay, so since we are actually having missing data, which is the none here, then we should be able to create dictionaries also. If we can create lists with missing data, we can create dictionaries also with missing data. And this is an example of creating a dictionary with a missing data, which is this here. I have the key C, and there is nothing assigned to that key. And I can create a series from that. So if I run this, it actually created. And in this case, instead of saying none, which is an object, because all of these are integers, then it actually create a series, but instead of creating it as integers as we did earlier, okay, here, because all the data was actually type integer, all the data was type integer. In this case, even though all the data are integers, but we have a missing component which is assigned to key C, which might be an integer or it might be a float. Therefore, it will take a precaution and it will create this series as a float, which makes it safer. Because if it's an integer, I can represent it as a float. And if it's a float, then I am safe. I don't have a problem with this not a number being replaced by a float. Because I can also replace it by an integer as a float or as a float itself. So I am safe that way. And that's done automatically by the function series for us. And of course, it used the keys in this case as the indices for these values to say that A contains 10, B contains 20, C is not a number, i.e. it's missing, D is 40, and E is 50, as it is in that series. Now, since we have managed to create a series, we can access this series because we said a series is similar to an array. And we saw when we talked about NumPy library how we access this array. So that doesn't change here. We should be able to access our series in the same methodologies that we introduced to access our array, by index, by slicing, and still using, or by some sort of a condition. Okay, so let's look first of all by accessing based on an index, and in this case the index are actually based on the keys because I'm using a dictionary to create the list. So I am actually saying I want to access this series using the index 0 or index, in this case, A or B or C. Okay, so I pass the index that I want, and I know that it's actually key B. Therefore, if I run this, it should actually give me whatever is stored at B. Now, if I change this to E, then it should actually give me whatever is stored at E. Or if I put A, it will give me whatever is stored at A, and so on. So let's bring it back for the sake of this example to B, then it's correct. But please play with these examples and try and change them, because that will reinforce your understanding. That's the only way you can actually understand what is actually happening in this piece of code. Otherwise, you will memorize it, you think you understand it now, but when you come back to using it in your own code to carry out some functionalities, you will be lost, and you will say, was it done this way or was it done that way? But if you practice it and you try it, then you will understand the actual logic of actually calling based on index or based on key, as we are actually working with it. You remember we also used slicing before, where we can actually call the content of an array from index 0 to index 5, or anything after index 3, or up to from index n to index n plus 5, and so on. This is how we actually accessed our arrays before. The same logic apply here when I'm slicing. And in this example, I created a list of numbers, and I created a list of indices, and then I wanted to actually access this list from index, the second index, all the way to the fourth index. Therefore, it will go and give me the values stored at the second index all the way up to the fourth index, remembering it's index 0, 1, 2, and 3. Okay, it's not 4. Therefore, index second contains 20, and index fourth contains 40. Therefore, it will go and actually give me the contents of these indices. So if I run this, it actually give me the same. If I say fifth, it will actually go and include 50, because I'm not looking at an index. I'm not looking at the automatic index where it's actually starting from 0. I am starting here with my own customized index, which is first. If I compare this index, which we have created here, with the automatic index, this will be index number 0. Okay? But it's actually forced customized index, so it's first. Therefore, you need to remember that I am ignoring first and I'm starting from second. Okay? And I go all the way to fourth, which is this one here. Therefore, I am not following the automated index format that we were using before. It is actually the customized, and that's why we are actually including second and including fourth. Okay, so let's take the second example, and this example is actually accessing a series based on a condition, and the condition I am actually using here is greater than whatever is the variable I want to use here, and I'm saying greater than 30. I can run this and it will actually give me 40 and 50, or I can say whatever is less than 30. If I say less than 30, it will now give me 10 and 20. If I say or equal, it should actually give me 30 also. So I can change this condition the way I want it. So this is the condition. So I am actually indexing based on conditions. Okay, and I'm taking the content which are there, and I want to see the index that is actually included. Okay, I can change the index if I have a data series which already created and it has its own indexing. I can actually go and change the index by calling a function called reindex. Okay, and in this case, this function will take the new indices that I am providing, and it will replace the series indices which originally were A, B, C, D, and E. And then if I print this index, something funny happens, which I need to talk to you about now after I run this code. So if I run this code, this is the series now. But if I print the series, which is the original series, and if I print, and there I can put the original series, and if I comment this, because I just want to talk about the original series. Now you see the series. What do I have? I have the index A to E and the content from 10 to 50. Now, if I bring this in new same series, but now it's exactly the same series, but what I did, I actually used re-index and I gave it new indices. Okay, now if I run this, look at this. This is my original series with the data type integer 64, and this is now my new re-indexed, or the same re-indexed series. But we have the results where we have not a number assigned to each index. And this is because when this series is actually re-indexed and we are using a different index, different type of index, it will go and reassign to that index nothing, i.e. it actually comes as not a number. It's supposed to be an integer, but it goes and assigns nothing to it in a float format because it doesn't know what to bring there. So if I want to fix this, then I need to change it, okay? And this way I can actually go and tell the series to actually go and insert in each index something, a particular value. So I can go and use fill value equal 0, and then it will take the new series and it will fill whatever value I indicate here. I can also use a series to actually enter here, and I can create the series all the way again. So if I do that, you can see now I have actually filled the value with this value, which is equal 0. So as you can see, I can change the indexing, and then I can replace the none by a value. So what I want you to do, I want you to change this code and to actually use the same values that we have put here to place them in these indices. And I want you to do it in the minimum amount of code. And if you can send me that via the comment or by email, I will actually reply to you. And if you have a problem with doing it, also I will reply to you. Just let me know by a message there, a comment, to say that you have a problem. Then I can communicate with you and I can tell you how you can do it. But for now, I want you to try it yourself. Okay. Now, we have seen that we can create series with missing data. So let's see that if we have missing data, how we can actually deal with it. But before we start looking at missing data, let's look at how we can create a data frame. And a data frame is actually series, but multi-dimensional series. That means that I can have more than one column in my data, because you said, I showed you before that a series is actually just an array. It's a one-dimensional array. Now, in data frames, I can actually now see that I can create a data frame using the data which is here, which is again, and I have two dictionaries, nested dictionaries, and I assign that into data, which is a dictionary, and then I used the function called DataFrame to take these two dictionaries and create for me what we call a data frame, and the data frame is a multi-dimensional series. Okay, so if I create this, you can see that I have now this two columns, column A and column B, and column A contains the data, which is 1, 2, nothing, 4, and 5, and column B contains nothing, 2, 3, 4, and 5. And then I actually called a function in which I wanted to know is that data frame, does it contain nothing? And this way, this function will tell me if there is missing data in that index or there is data. It will give me true if there is data present, and it will give me false if the data is missing. Okay, so what did it actually do? It actually takes the first value in A, is null, and it says, is it false? Because it's not null, it's actually, there is data there, therefore it will return false because it's not null. Then it will look at the second one, and there is data, therefore it's not null. It will look at the third index, and it will see that it actually doesn't contain any data, therefore it will come back and it says it's null, it's true, there is no data. And again, it's false because there is data, it's false because data. Then it goes to column B, and it will look at the first component, and it says yes, there is no data, and then it looks at the rest of it, and it will say no, there is data, and it will return false for each of them. Therefore, I have a function which, when I use, I can actually see how we can actually check whether there is data or whether there is no data in my data frame. Now, let me go further down here and give you how we create a data frame, and it's just calling this data frame, and I have actually gave the examples about missing data at the top. So if I come here, I will come back to these cells are there, and you can see I can create a data frame from list, and I have in here a dictionary, and I have the key, and in the dictionary have the key, and then it has a list, and age as a key, and it has another list, and city, and it actually a key, and then it have a list, which is all of these are within this dictionary. So then I pass this to this function, which is data frame, and it creates the data frame for me. And as you can see, it actually presented it as column, name, age, and city. And this is actually the index, which is 0, 1, and 2. And you need to understand that this index is not part of the data frame. It's just telling me at index 0 there is this data, and it comes in the form of columns. Okay, so name column, age column, and address column, which is in the city. Okay, now we can access this data frame by passing the keys of which is this is the key for this column, this is the key for this column, and this is the key for this column. So if I want to access this column by names to see what are the names in this data frame, then it should actually tell me the names in the data frame. Or I can actually say I want to access it based on if I have something else, which is salary. Do I have this there? It actually have the salary, or I can add, sorry. What I did, I have this data frame here, and then I called the data frame, and then I passed it a new column called salary, and this column actually going to have this list. So it will use this as the index, and then it will add to this index as the column, it will add to it 50,000, 60,000, and 70,000. And you can see if I call this new data frame with the new column, it actually added salary there, and my data frame now is actually containing 4 columns: name, age, address, and the salary of each of these persons in this column, which are the names Alice, Bob, and Charlie, and their individual salaries. Now I can actually access the data frame again by passing the key and based on conditions. So the key is the name of the column, and I want anything that's less than or equal 30, and that will give me 25. And then I can also anybody that is less than 35, so it should actually give me Bob, which is less than 35, and the first one will say greater or equal. I accessed, and then I can print on this condition. So let's see. In here I accessed, and in here I printed, and I used in the print whatever I actually looking for. So and then I printed young people to actually say that. So see what I have done. First one, Alice is 25, because that satisfies the condition which is less than or equal. And then I wanted to print the actual age under this condition, which is less than 25, and it will say that it's actually Alice, and it actually gave me the young people, which is Bob, which is 30, which is actually taken. His address is San Francisco, and he's actually earning 60. This guy's address is in New York, and he's earning $50,000. So this is how we can do. So we can create a data frame using this dictionary again, where I only have the indices A, B, C, A, B, A, B, and A, B, where I'm actually saying that I have repetitions of A, and it actually contains 10, and it contains 30, and it contains 50. And I can actually, once I create this data frame, I can go and access this data frame and do some calculation. So let's first of all print the data frame. And we know that the data frame is called df. Okay, and let me comment this. So if I run this, it gives me the data frame. And look at this category. I have A, and I have B, and B. And I have, in each category, I have 3 values. Okay. Now, if I access that based on category, and I want the mean for each category, that means the mean, I have to sum them and then divide them by the number of repetitions, and it should give me the value. And can you see A mean is 30 and B mean is 40, because what it's done, it's actually 10 plus 30 plus 50 and divide by 3. 90 divided by 3 is 30, and I have 20, and I have 40 and 60, and if I add them together and divide by 3, it should give me 40. And that's how I can actually do some calculation on this data frame which I have created. I can also group based on column. Like if you look at this, I have A, and I have the values as before, but I also put a type, and I said type X, X, and X, and Y, Y, and Y based on the category A and B. Okay, if I also print the data frame here and comment that and run the code, you will see that I have a category A, B, A, B, and I have the type XY, 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 and I have the values as they are stated there. Now, if I uncomment this and run based on the sum of these two categories, then I say that A, which is category X, the sum of all the values are 90, and B, the category Y, and the sum is 120. Therefore, I can do many of these mathematical operations here. Or I can actually do the mean, the sum, and the count all together, and I can actually use aggregate of these functionalities. So I group by category, then I will call a function called AGG, and I can pass it the value, and I want mean, sum, and count, and it will go and call the function mean, the method mean, and the method sum, and the method count, and it will actually do the calculation for me. And if I run this again, it should actually give me the mean for all of them, for all the categories which are A and B in this data frame. Sorry. Now, also I can group by customized aggregation, and then I can go and apply custom aggregation function. I can use lambda, and we have seen how we can use lambda, and in here I want to look at the minimum and maximum X, and I can actually go and categorize them based on that, and we can actually go and see how we can group the values for the category A and B, and we can see that it's actually the minimum and the maximum of these two custom aggregation. So if I run this code, can you see I have category A and it gives me 40, and category B it gives me 40, and that is how it can actually be categorized. Now I can go back to the code which I have skipped there, which is the actual missing data. Now we've talked about data frames. I can go back and talk about the missing data, because I'm going to be accessing data frames and replacing data within the data frames themselves. So this data frame, we have this accessing missing data in a data frame, and I showed you that we can actually go and exclude the data frames by dropping the data, and to drop it I actually use the function drop, okay, and I passed it the column axis 1, or I can actually go and drop by row, or I can drop by column. So I can actually drop by column that contain a missing data, any missing data, and then I can drop just by row or by column. So let's see how that works. The first one is actually going to look at anything that any row that have missing data, and it will drop it for me. Okay, so let me comment this and this and this, okay, and comment all these which are actually related, so we don't clutter what we are doing, and we just keep this here. So if I run this, this is my data frame, and what I have done, I have actually fill the missing data in the first one, and with a specified value. And what I did, I called the function fill, and I passed 0 to there. So it will see where there is a missing value, and it's actually the third, and it goes and puts 0 there, and it's the first, and it goes and puts 0 in there. Then it actually goes and print the filled data in here, and I can say that I can use fill, but I can specify a data, and it doesn't have to be a number. It can be any type of data, and I can fill it again, and it actually went and printed it for me. And can you see it actually said it's fill value, full value. So in there I used a 0, and in here I used a value, a specified value, not a number that I want. So this will show you that we can actually do the filling with anything that we are trying to do. So let's comment this here again also, and comment no, leave that as it is. Okay. So let's now comment this, and let's go and look at this and see what will happen. And I want to call diff filled, which is there. And if I run this, can you see now it's actually gave me the filled data again, and it specified what I filled, and as I specified. Let me say I want to make this into 8 and run, and it should actually change it for me. So this is how we fill data. Now we can use forward fill or backward fill. Now if I'm using forward fill, that means I will take the value before the missing data, and I will enter that into the missing data. So in this category A, the value which I will use for this missing data will be 1 if I'm using a forward. If I'm using a backward, I will use this 3 to fill the data. And in here, if I'm using forward, I will take this 20 to fill this, and this 40 to fill this. So if I print this, let me just comment this and this, and let's just look at the forward fill. Can you see in the forward fill, I said we will take this and we will insert it here. We will take the 3 and we will insert it there. We'll take the 20, insert it there, and we'll take the 40 and insert it there. And that's what we did. We took the 1 and inserted it, and we took the 3 and we inserted it. We took the 20 and we inserted it, and we took the 40 and we inserted it. Therefore, we have managed to fill with the forward fill. Now, we can actually do the same with the backward. If I comment that related to the forward, and if I run the code now, you can see now I took the 3 and I put it in the place of the missing value, and I took the 5 and put it in place of the missing value. So I can actually now do the forward and the backward depending on what I want, or I can go and take an average, or I can do interpolation to actually fill the data. So it's endless what I can do to actually fill my data. So let's look at this, and I want to do interpolation. And what the interpolation will do, it will actually take this number and this number, add them together, divide by 2, and give me a value to put here. Okay, that's only taken just these values, this one and this one, the one before and the one after, and I will enter the actual average of that, and we call that interpolation. Which is interpolation, it means the number in the middle between the two. Okay, so in this case, since I'm going to use interpolation, then I called a method called interpolate. Okay, it will find where there is this missing data, and it will actually interpolate, taking the number before and the number after, and take whatever sits in the middle between them, and it will give me the new frame. So what it did in here, it took 3 and 4, and the number between them is 2, therefore it inserts 2. It took the number between 3 and 5, and it's actually 4, therefore it actually gave me 4 there, and it filled that category for me. For this one, it actually took the number between 20 and 40, and it actually entered 40. It took the number which is 30, sorry, and it took the number between 40, and there is nothing after it, therefore it takes that 40 and it entered 40 for me. But if I had another number there, it will actually interpolate between. So between 40 and 40, there is only 40, therefore it actually put 40. And this data frame part I have covered for you earlier. Now let's look at examples to reinforce our understanding. And in here, I want to apply some of the cases where we can actually, for example, calculate. I create a data frame, and then I go and calculate, for example, the standard deviation of sales, because I have here names of company in this dictionary, the persons who are owning or working in this company, and the particular sales. So this could be the names of the salesmen, owners, whatever you want them to be, but it's the name of the person in that company. So if I create the data frame, it should give me the index for data frame, then it will give me the company, Goog, and I have two people, Sam and Charlie, and then I have another company called MSFT, and I have Amy and Vanessa, and then I have another company called FP, and I have Carl and Sarah working there, and their sales are actually according to the numbers which I specified here. Now I can create a data frame with that, and this will be, I have two people in Goog, and Sam and Charlie, and their sales are 200 and 120. Then I have two people in MSFT, Amy and Vanessa, and their sales 340 and 120. And then I have in the third company, FMP, I have Carl, and I have Sarah, and 230, 243 and 350 their sales. Now I can find the standard deviation for the sales. So what do I do? First of all, I created the data frame, then I grouped the company, the data frame based on companies. Okay. So if I group it based on company, that means I only select the column with the company. Okay. Then I took that a new data frame, which is now just containing one column, which is the names of the companies, and then I went and passed to it the name of the column sales, and I called a method on that column which is standard deviation. Okay, and now in there it will go and calculate the standard deviation for that company. Now if I run this, it should give me the values of this standard deviation. Now, for most of you who don't know what we mean by standard deviation, because probably you didn't do any statistics. Now, when we do standard deviation, we need to say, for this example, we need to understand what we are calculating. And if you allow me to actually share now with you this board, and then I can explain to you what I mean by the standard deviation and how we calculate the standard deviation. So I'm going to use this board here, and you need to understand that Pandas defined standard deviation method, which is called STD, which we have already seen. So the standard deviation method, standard, oops, it is, I am actually, because I'm very tight here in front of my computer and my table is very small. So if I actually come back here and look, I have a method standard, and we actually use it to calculate the standard deviation. It actually, because the mouse is too close to my tab, it's actually giving me used to calculate standard deviation. And the sample or observation sample standard deviation S is defined as S is equal to the root square of the sum between I equals 1 to n of all individual observation, which is x of I minus the mean squared over n minus 1. Okay? And in this case, S is sample standard deviation. Now, what do I mean by sample? You remember in our data frame what we had? We had individual values, which are, let's say, 50, 60, 70, and 80. Now, these are individual samples. Okay, sample 50, sample 60, sample 70, sample 80. So I will calculate the standard deviation for each sample. How do we calculate that? I will show you. And then n is the number of observation. and xi is the individual value, and then x hat is actually the mean or sample mean. Now we need to calculate this. Now let's say we are actually taking company Goog from our example, and in this we have a group which is called Goog, and we want to calculate the standard sample standard deviation. Sample standard deviation. And let's go back here and see what was our sample here and what we have. We have the values for Sam or for Charlie, which are 200 and 120. So let's go back here, and I have n equals 2, and I have x1 equals 200 and x2 equals 120. Then step 1, I will actually calculate mean. i.e. x bar or hat, and this is calculated by saying it's x1 plus x2 over n, and it should give me 200 plus 120 over 2. And that should give me 160. Then I need to calculate the square difference. Because I'm looking at this equation here. First of all, I calculated this for this sample, and then I need to calculate this now, which is xi minus the mean, and I need to add both of them because I have two of them. So for the first one, it's actually x1 minus x hat squared, which means it's actually 200 minus 160 squared, which should give me 40 squared, which equals to 1600. And the same for x2 minus x hat, which is the mean, squared. It's actually 120 minus 160 squared, which equals minus 40 squared, which equals 1600 again. Now the third step is actually finding this summation. which is I equals 1. So we start at 1 and we go all the way to n. And all I'm trying to do is say x I minus x hat squared. And this will actually be the first number, which is the sum, which is 1,600 plus 1,600, which is, sorry, it will be 1,600 plus 1,600, which will equal 3,200. And step 4 will be to actually go and get the root of these values for me. That will be step 4. So let's go to step 4. Step 4, we calculate the variance. In statistics, we call that variance, which is what we have actually done at the top, which is this value over n minus 1. And that is given to us, which is I equals 1 to n of x of I minus x hat squared all over n minus 1, which should be the 3,200, which we have calculated here, over n minus 1. And we know this is actually n is 2 minus 1 is 1, therefore it equals 3,200. And this is step 4. Step 5 will be to calculate S, which is, we called it sample standard deviation for each sample, for each category if you like also. And that will be S is equal to the root square of the variance. Okay, and that will be the root square of 3,200, which actually equals 56. 56.57. So that means we have to repeat this for each of the samples which are actually in the data frame. Okay, I just wanted you to see what we actually do there. So if I go back to the code after we did this explanation, okay, I bring my mouse back here so I can go back to working again with my Jupyter notebook. So can you see Goog calculated 56.56, which is actually 56.57. I calculated it, but not much difference between what I did and what would the computer do. So it actually goes and do this for each of the samples, okay? And it actually calculated them for us, as you can see there. So we have 3 companies, and then we got the standard deviation of the sales, which is something that meaningful to us. It will give us an indication of the company's sales and how we can actually do a lot of the manipulation of the data frames. Okay, you can look at the second example, which is grouping, and the last one I want to talk about is actually transposing. When we look at the data frame, if we have a data frame that actually looks this way, where we have the companies, and then we have the columns, which is in here: count, mean, standard deviation, minimum percent, 25%, 50%, 75%, and 100% of their sales. Now, if I want to look at it transpose, where I want to actually flip it, then I will use what we call a method called transpose, and I will call it on this data frame, which is actually here printed, and it's called I call it describe, because this is the description of the data frame, and it will go and actually print it the other way around for me. Well, it will use the names of the columns as the first column. It will actually takes it, convert it from a row to a column. So it will convert everything for me from a row to a column, and it will display it in a different way. So this is how we can actually manipulate. Please look at the rest of this code here. It's very simple. It's well explained, and I will stop this video here because we have been going for over an hour now. So thank you very much for watching this video, and I hope to see you in the next video.